Assalamualaikum. So for part introduction 1.1, steady flow device maintain constant parameter which is temperature, pressure and velocity. The zeroth law of thermodynamic established thermal equilibrium, allowing the definition of temperature scales and the use of thermometer. The second law of thermodynamic impose limitation on the efficiency of that engines, highlight the irreversibility of some process and the tendency of system to increase entropy. The key equation for steady flow device involve the conservation of energy, accounting for heat transfer, work and mass flow. In 1.2, importance of studying SFD. Steady flow device including pump, compressor, diffuser, nozzle and heat exchangers are integral components of energy system facilitating the regulated transfer of mass and energy. Heat exchanger contribute significantly to energy conservation, process optimization, and heat recovery in various industrial and commercial systems. The significance of studying steady flow device extend beyond theoretical understanding to practical application in engineering, design, and innovation, influencing the direction of technology for environmental sustainability. In 1.3, which is objective, first, to identify the working principle of a heat exchanger. Second, to explain the application of heat exchanger in industry. Third, to understand the process of temperature change and flow in a heat exchanger. So for background and theory, 2.1 thermodynamics law, there are three law in this thermodynamic, which is zero law of thermodynamics. Body in thermal equilibrium with a third body are in equilibrium with each other. Second, first law of thermodynamics express the conservation of energy principle. Energy cannot be created or destroyed, only transformed from one from to another. Second law of thermodynamics focus on entropy, stating that energy has both quality and quantity. Without energy entering or leaving the system, the potential energy of the state always decreases. Waste heat is considered a part of energy loss. For thermodynamic properties, there are eight types of properties. First, pressure, force exerted by a fluid per unit area. Second, temperature, a physical number called temperature can be used to quantify the idea of hotness or coolness. Third, volume, the amount of space occupied by a substance. Fourth, energy, internal energy, the sum of all microscopic forms of energy in a system. Fifth, enthalpy, the total heat content of a system at constant pressure. Six, entropy, a measure of the disorder of randomness in a system. Seven, specific heat, the amount of heat required to raise the temperature of a unit mass of a substance by 1 degree Celsius. The last one, density, which is mass per unit volume of a substance. Thermodynamic process also have eight process in the thermodynamic, which is quasi-equilibrium process, which when a process proceeds in such a manner that the system remains infinitesimally close to an equilibrium state at all time. Second, isothermal process is the process during the temperature is constant. Isobaric is the process during which the pressure is constant. Isochoric or isometric is the process during which the volume is constant. Adiabatic process occur without the transfer of heat to or from the system. For six, process, reversible process, a process that can be reversed without causing an increase in entropy. Irre- Irreversible process, a process that cannot be reversed without an increase in entropy. Last, steady flow process, fluid flow through a controlled volume with constant mass and energy. The process did not change with time. There are two parts in 2.3, that is control volume and control surface. For control volume, also known as an open system, is a defined space for analysis, typically contains mass flow equipment like turbine, compressor, or nozzle. Energy or mass can pass through the control volume edge. Internal control volume simplifies fluid flow analysis through the device. For control surface, a boundary of a control volume representing channel for mass, energy, or other attributes to flow through. Application of mass and energy conservation concepts necessitate the use of control surface. A boundary is defined as the real or imaginary surface that separates the system from its surrounding. For steady flow device, it maintains constant temperature, pressure, and velocity at any position within the device during operation. Fluid continuously flow through a control volume inside the system. Steady flow process involve constant parameter and maintains constant mass and energy throughout the operation. This is for the definition of steady flow device. And it has four characteristics of steady flow device, which is constant properties, continuous flow, energy transfer, and analysis using control volume. Principle of thermodynamics and energy conservation. The equation U is equal to Q uh, minus W express the law where U is the change in internal energy, Q is the heat added, and W is the work done. This law is fundamental in understanding energy transformation, applicable to heat engines, thermodynamic process, and technical application. The thermodynamic system, enclosed by real or imaginary limits, is part of the universe, while the rest is the environment. System can be open, which is exchange matter and energy, closed, exchange only energy, or isolated, exchange neither matter nor energy. The zeroth law of thermodynamics states that thermodynamic process do not affect the total energy of the system.